Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as I go through all that you need to know for next Thursday's test on trigonometry and linear relations. So we'll start with the trigonometry. It's actually a very small component of the test. There'll just be a couple of questions and it's all about finding angles. Now, one thing you just have to remember when you're finding angles with trigonometry is, of course, SOHCAHTOA. So it's the same SOHCAHTOA, everything has the same meaning as when we were finding sides, although you're not going to find sides in this particular test. So of course remember, we use the sine ratio if the question involves the opposite and the hypotenuse. We use the cos or the cosine ratio if we have the adjacent and hypotenuse. And we use tan if we have the opposite and adjacent. Of course, remember the first letter goes on top. So for sine, for example, it's opposite on top, hypotenuse on the bottom. One extra though, when you are finding angles, as we will be in the test, you don't use sine, cos, or tan, you use sine inverse, cos inverse, or tan inverse. And remember, you do that on your calculator by pressing second, and then sine for sine inverse, or second, then cos for cos inverse. Make sure your calculator has a D like this at the top that you can see. That means it's in degrees mode. If it's not, if you can't see that, make sure you ask your teacher and get it changed so that it becomes in degrees mode. Okay, let's just go through a couple of quick examples. So let's say we have a right angled triangle like this. I want to find this angle theta, and I know this side is, say, 1, and this side here is 2. I know it's not drawn to scale. So what I do is I go to my SOHCAHTOA here. So in relation to the angle I want to find, I have the opposite side and the adjacent side. So that means, of course, I use tan, but because I'm finding an angle, I use tan inverse. So in this case, theta will be the tan inverse of opposite over adjacent. And I just put that into my calculator. So if you're in degrees mode, the number that comes out is 26.565. I'm just going to round it to the nearest degree, so it's approximately 27 degrees. So let's say I have this new triangle here and I want to find the angle theta. So I've got the opposite and the hypotenuse. So of course I have to use sine, and I use sine inverse because I'm finding an angle. So in this second triangle, theta would be sine inverse of opposite over hypotenuse. Make sure you get them the right way round, because if you did sine inverse of 11 over 6, your calculator gives you an error. And if you do that right, you get an answer of about 33.1. This time I've rounded it to 1 decimal place. That's all you need to know for trigonometry and finding angles. So let's go on to linear relations now. Okay, so for the linear relations bit, first we have to understand plotting points and writing their coordinates. So this is something you've been doing since year 7. So remember, if you want to write the coordinates of a point, they have to be in brackets. We always write the x-coordinate first. So if I want to write the coordinates of point A, the x-coordinate here is 1. I've started at the origin and I've gone across 1. So x-coordinate 1, comma, right coordinate, y-coordinate, is 2. So that's how you write a point. You just have to make sure you write brackets so we know that it's an ordered pair. So let's say I want to now plot a point. So let's say I want to plot the point 5 minus 4. So again, first number is always x, second number is y. So I start at the origin and I go across to x equals 5, which is here, and I go down to y equals negative 4, which is there. So that is the point B. Okay, so plotting points and writing their coordinates is really, really easy. So if I join these 2 points up, I have a line segment. So I call the line segment AB. It's a line segment, not a line, because it doesn't go forever in both directions. A line has to go forever in both directions. So what you need to be able to do, you need to be able to calculate the midpoint, distance, and gradient of a line segment. So I'm now going to show you how to do that. So firstly, for midpoint, we just want a point that's on that line segment that basically cuts it in half. It's halfway between point A and point B. So what we want to do is just find the middle of the x values and the middle of the y values. So to give you the formula, I'm going to first label the points. So I've got a point A and a point B. I need 2 points for the line segment. So I'm going to label A the first point and B the second. It doesn't really matter if you label it the other way around. So this number here, 1, that's the x coordinate of the first point. So I call it x1. And this number here, 2, is the y coordinate of the first point. So I call it y1. And then 5 is x2. Negative 4 is y2. So the midpoint formula, so the midpoint M, is add the 2 x coordinates and divide by 2, and then add the 2 y coordinates and divide by 2. Now you can't put this whole big thing in brackets and the comma into your calculator. You need to do the x value separately on your calculator, if you need a calculator that is, and you need to do the y value separately. So for the line segment I have there, it's very simple. I just go x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. You can use your calculator if you're worried about the negatives here. It doesn't matter, okay? So the answer I get, 1 plus 5 divided by 2 gives me 3. 2 plus negative 4 divided by 2 gives me negative 1. My answer is a midpoint, so it needs to have brackets and a comma between them. So the midpoint of this line is 3, 1. So x is 3, y is negative 1. It's this point here that divides it in half. Okay, I'll just point out very quickly that on the test you'll have the Cartesian plane already drawn up for you. You will need to label it, but you won't need to waste time, ruling out and measuring the distance along each axis. Alright, I'm going to rub this out now, so please pause and copy down if you need it. I'm now going to go through the distance formula. So I'm now going to calculate the distance of the line segment, and to do that, I'm going to use Pythagoras, because this red line, it's the hypotenuse of a right-angled triangle. So I can make a right-angled triangle like this. So this distance here is just how far I've gone across. It's the difference in the x values. We can see we've gone across from x is 1 here to x is 5 here. So the distance here is 4 units. Whereas this line here is how far I've gone up. So I've gone from -4 to +2, so I've gone up 6. So I can easily calculate the red line, how long it is, using Pythagoras. So remember, for Pythagoras, you can jump straight to the answer. So C, the hypotenuse, is the square root of a squared plus b squared. A and b are the shorter sides. So in this case, it's the square root of 6 squared plus 4 squared. Okay, so that's obviously just equal to the square root of 52, which is the exact value, and to 2 decimal places, that is 7.21. Okay, so we don't actually know whether it's centimeters or whatever, so we can just write units. So the length of the line segment AB is 7.21 units. Now sometimes though, you'll have to find the line segment, you'll be told the 2 points, but you won't be given a diagram like this. So in that case, we can just use the formula. So the distance formula, I'll call it D for distance, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so the reason for this formula, this is how far we've gone across. It's that length there. This is how far we've gone up, the difference in y values, it's that length there. Because there's a plus in the middle, it doesn't matter if you write the y's first before the x's. So I could use this formula to solve the problem I just did. So it would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and again, if you put that in your calculator, you get the same answer of 7.21 units. Now, just make sure that you put the brackets in the right spot. So notice that the squared is outside the brackets in both cases. Okay, so that's how you find the distance. Simple stuff. I'm going to rub this out now and go through how you find the gradient of a line segment. Again, please pause and copy down if you need this. Okay, so now I'm going to calculate the gradient of this line segment. So the gradient tells you how steep the line is. The higher the number, the steeper it is. So if a line was like this, really steep, it'd have a high gradient. A line that wasn't so steep like that would have a low gradient. So the number is just an indicator. It allows you to compare the steepness of one line with another. So the gradient, which we call m, is just the rise over the run. Okay, so the rise is how far you go up or down, and the run is how far you go to the right. So the way I said in my class to do it was start with the leftmost point, which in this case is A, and figure out how you get to B. So to get from A to B, I need to go across 4, which is down here, across 4, so the run is 4. Now, I need to go down 6 to get to B. So I put a 6 up here because I went down 6, but if you go down from the first to the second point, the gradient's actually negative. If a line segment or a line leans to the left, so leans this way, that means that the gradient is negative. And if it leans right, the gradient is positive. So we'd expect a negative gradient here. So because we went down, it's a negative gradient, so it's negative 6 over 4. Which is negative 3 over 2 if you simplify it, or negative 1.5. So what that means is for this line segment, for every 2 I go across, I go down 3. That's the simplest way of saying that. So again, we did this using a diagram, but you need to be able to do it without using a diagram. And that's why we have the 2-point formula. So you need to be able to find the gradient of these 2 points even if you're not given a diagram, because drawing a diagram might take you too long. So this is the 2-point formula. M equals, the rise is just the difference in y values, and the run is just the difference in x values. So again, this is how far I go up or down, this is how far I go to the right. Now, the good thing about the 2-point formula is you don't ever need to think to yourself, oh, does the line lean left or right? This formula will tell you whether the gradient is positive or negative without you having to think about it. So let's put in the numbers again. So the gradient is y2 minus y1 over x2 minus x1. So negative 4 minus 2 is negative 6. 5 minus 1 is 4. We got the same answer. So it's really important you remember that in the formula, the 2-point formula for gradient, y's go on top. It didn't matter with the distance formula whether we put the y's first or the y's second. It does matter for the gradient formula. Y's on top, x's on the bottom. Alright, I'm now going to go through how to graph lines really quickly. Okay, so now we're actually going into graphing, where you're given an equation and you need to turn it into the graph of a straight line. We're only looking at straight lines. So I'm going to go through 2 methods for you. I want you to note, firstly though, table of values is a valid method. You can use that. That's where you pick the x values, you substitute into the equation, find the corresponding y values, plot a whole heap of points, and join them up. You can use that. I'm not going to go through it in that video, so ask me or your teacher if you want some more explanation on that. But it turns out that if there are any 2 points on the Cartesian plane, there is one and only one line that goes through them. So both the methods I'm showing you, if you understand them, they're quicker, because all we're doing really is locating 2 points on the line and joining them up. So the first method I'm going through is the gradient intercept method. That's easiest when your equation is in the form y equals mx plus b. So, for example, you might have the equation y equals 2x minus 3. It's in the form y equals mx plus b because it's y equals something. So the number in front, when it is in this form, the number in front of x is the gradient. So here the gradient is 2. The other number by itself is the y-intercept. So the y-intercept here is not positive 3, it's negative 3. This negative belongs to the 3. So we follow these 3 steps. Plot the y-intercept, we use the gradient to find a second point, and we join them. I'm going to do a rough sketch of this graph. Of course, yours will be a lot neater, and the Cartesian plane will already be there for you. Okay, so this is what we do. We mark out some points here. and we just plot a couple of points. So I'm going to plot the y-intercept at -3 down here. Then using the gradient to find a second point. So I told you before, gradient is rise over run. So if the gradient's 2, it's 2 over 1, because 2 is the same as 2 over 1. The number on the bottom tells you how far to go to the right, and the number at the top tells you how far to go up or down. So I start at my first point here, I go across 1, because the run is 1, and I go up 2. I go up because it's a positive 2. If it was a negative 2, then I would go down. I'd go across 1 to the right and down 2. Now, because it was positive, I went up. I now have 2 points, and all I do is join them up. Now, your line needs arrows on the end because it's a line. It goes on forever. Now, this diagram here isn't right yet because I need some numbers on the number plane. If I just don't label them, how do I know that this isn't -3 and this is -6 and this is -9? I need 2 points to be labeled on the line. So I label this one here at -3, and this second point I went to was the point 1, -1. Goes through that point. That is now correct because y equals 2x minus 3 is the only point that goes through these, the only line that goes through these 2 points. Make sure you also have the x and y axes labeled, but you must have 2 points clearly labeled on the line like I have here. Okay, that was the first method. Now I'll show you the second method. Alright, so we need another method of graphing because the other one isn't always that easy to use. So I said before, when the equation is in the form y equals mx plus b, we can read off the y-intercept and the gradient really easily. But what if it's not in that form? What if it's in this form? Now we could transfer from this form to the other form. That is a lot of work. You still need to know how to do it. But if you're asked to graph an equation of this form, graphing's already hard enough. Let's just find an easier method to use than rearranging our equation. The strategy here for the xy intercept method is exactly the same. We're just going to find 2 points that lie on the line and join them up. Of course, it turns out that those 2 points we plot are the x-intercept and the y-intercept. So we find the x-intercept by letting y equal 0, and we find the y-intercept by letting x equal 0. And in each case, we have something to solve. Let's do a very quick example. So let's say I have 2y minus 3x equals 6. Okay? You can't look at this equation and say, oh, cool, the number in front of x is -3, therefore the gradient is -3. That's not right. The gradient is the number in front of x only when it is in the form y equals mx plus b. This equation is not in that form, so we can't tell from this what the gradient and y-intercept are. That's why we're using this method. So I'm going to follow these steps. So first step, find the x-intercept by letting y equal 0. So this is my equation, 2y minus 3x equals 6. If I let y equal 0, I just get rid of everything attached to the y. And I'm left with minus 3x equals 6. So to find x, I undo timesing by -3 by dividing by -3. And that, of course, gives me -2. So the x-intercept of this line is -2. Now I do the same sort of process. I have my equation 2y minus 3x equals 6. Now this time, x equals 0. So I can get rid of the x's. I'm left with 2y equals 6. So y is just 6 divided by 2, which is 3. So I've got the x-intercept, I've got the y-intercept. Now my third step is I'm just going to join them up. So for this, the x-intercept's going to be over here at -2. The y-intercept is going to be up here at 3. Notice that I've labelled these 2 points clearly, so that's enough. I don't need to label the rest of the plane and do all the divisions and all that. So I just draw a line between them, and I'm going to write the equation of the line 2y minus 3x equals 6. You should also always do that. And of course, I'm going to label my axes as well. So that's it. the line is now graphed using the XY intercept method. Okay, just a couple more things to go through. Rearranging equations and then finding the equation of a line. So even though it's hard and it's annoying and we don't want to do it, we still need to know how to rearrange equations. So you might be asked to take this equation and write it in the form y equals mx plus b. In other words, make y the subject of the equation. So we probably don't want to have to do this if we have to graph this line, because it takes a long time. But you still need to know how to do it. So, how do we do it? I want to get y the subject, so I have to undo everything that's been done to y. This isn't a new concept to you, but people freak out because there's also another variable here. But we don't need to treat this any different. So let's write the equation again. 2y minus 3x minus 6 equals 0. So I want to get all this stuff over to the other side. So firstly, I'm going to move the 6 over to the other side by adding it. So, because what undoes subtracting 6 is adding 6 to both sides. Okay, minus 6 and positive 6 cancel each other out. That's why I did it. So now I'm left with 2y minus 3x equals positive 6. Now, I want to get this thing over to the other side. So think about, what have I done to y? I've times y by 2, and I've subtracted 3x. So to undo subtracting 3x, I add 3x to both sides. I don't want to get x by itself, that's why I'm not dividing by negative 3. So when I do that, negative 3x and 3x cancel out, that's why I did it. 2y equals 6 plus 3x. Now you may think we're done here. We're not done yet, because I don't have y by itself, I have 2y by itself. And I want y by itself. So I'm going to undo the 2y, undo times by 2 by dividing each side by 2. When I do that, I have to divide everything on the right hand side by 2. So of course 2y divided by 2 gives me y. 6 divided by 2 is 3, and then I can just write 3x divided by 2, or 3 over 2x. Now, this is in the form y equals mx plus b, so I'm done. So it actually turns out that for this line, the gradient wasn't the number in front of x, which is negative 3, the gradient is 3 over 2, and the y-intercept is 3. Okay, so that's how you rearrange equations. I now am just going to go finally through finding the equation of a line. So when we're finding the equation of a line, we need to remember that any line can be written as y equals mx plus b. So all we need to do is find what m is and find what b is. Unfortunately, what makes this complicated is you do it differently depending on the question. So let's first look at what we would do if I have a graph. So let's look at this graph here. So I'm trying to find the equation of this black line here. I want to find what equation I would graph that looks exactly like that. So I'm just going to follow the steps. So my first step is I need to find m. I know that m is the rise over the run. So as I said in a previous example, I start at the leftmost point and figure out how I got to the other point. So here I've gone across from x equals 0 to x equals 6. So here I've gone across 6. The run is 6. 6 to the right. Now, to get from this first point, at y-intercept is 3, to get from there to there, I've gone down 3. So the rise is actually negative 3. It's negative because I went down. If I went up to get from the first point to the second point, it would be a positive number on top and a positive gradient. But the gradient should be negative because the line leans to the left. Now the second step here is really easy. The y-intercept is already marked. It's just here, it's 3. So b equals 3. So the equation of this line is just y equals negative 3 over 6x plus 3, or if you like, negative a half x plus 3, because negative 3 over 6 is negative a half. Okay? So that's done. Okay? I've got to show you 2 more types of questions, so I'm going to erase this, pause and copy down if you need. So I'm going to attempt these 2 questions that are now on your screen. So, because both of them say find the equation, I'm going to use the exact same process. Find M, find B, and then I have my equation. So let's look at the first one. Find the equation of a line that has gradient 3 and passes through the point 45. Well, clearly, the gradient is 3. We were told that. So step 1 is done. Now, to find B, what we do is we take our equation y equals mx plus b, because any line can be written in this form. And what we do is we substitute m, x, and y to find b. So I know what m is. M is clearly just 3. So I'm going to replace m with the number 3. Now, how do I find x and y? They come from the point that you're given. So here, of course, in the point 4, 5, x coordinate is 4, the y coordinate is 5. So I'm going to take my equation and I'm going to substitute x to 4 and y to 5. So I now have the equation y equals m times x, sorry that's a times, plus b. So 5 equals 12 plus b, because 3 times 4 is 12. Solve for b, I subtract 12 from both sides, so b is minus 7. So therefore, the equation of the line is y equals mx plus b. Y equals 3x minus 7. Let's do the last question. So for this one here, this is the hardest of all of them. I don't have a diagram, so I'm going to need to find the gradient. Now I could plot these points and draw a diagram and do it like the first example, but that's going to take a long time. So when you have 2 points, to find the gradient you use the 2-point formula, y2 minus y1 over x2 minus x1. Okay, so first point, remember, is x1, y1. Second point is x2, y2. So the gradient is y2 minus y1 over x2 minus x1. So negative 4 minus 4 is negative 8. And then 5 minus 1 is positive 4. Negative 8 divided 4 is negative 2. So I've done step 1 and found the gradient. Step 2, I'm going to do just like I did in the previous example. I'm going to take my equation y equals mx plus b, and I'm going to substitute m, x, and b. So I know that m is the gradient negative 2. So I write negative 2 in front of x. Now, I'm going to substitute x and y. It doesn't matter which point I use, so I'm just going to use the first one. So I get y equals negative 2 times x. The x coordinate of the first point was 1, plus b. So now I have 4 equals negative 2 plus b. So I add 2 to both sides. I get 6 equals b. B is 6. So therefore the equation of the line is y equals mx plus b. Okay? Now unfortunately there are some special cases of this I need to go through. So the special cases, they are lines that are perfectly vertical or perfectly horizontal. They're ones like x equals a number or y equals a number. So if they're of the form x equals a number, they are perfectly vertical, and it's counterintuitive, but x equals a number, they're parallel to the y-axis, okay? And y equals a number is the opposite. So, if I wanted to graph something like x equals 2, I just label the point 2, and the graph is a perfectly vertical line through it. It's parallel to the x-axis. So that one, of course, is going to be the line x equals 2. If I want to graph the line, say y equals negative 3, I go down to negative 3, and I draw a perfectly horizontal line. It's parallel to the x-axis. So that would be y equals minus 3. Now these two points happen to have a point of, these two lines, happen to have a point of intersection, and the point of intersection is 2, negative 3. So if I was asked a question like find the equation of a line that's parallel to an axis, it's going to be one of these. It's a special case, not like the previous ones. So if I'm asked a question like, what is the equation of the line parallel to the x-axis but 3 units down? So remember, if it's parallel to the x-axis, then it's y equals a number. 3 units down means it's 3 units below the x-axis. So that's the one we just graphed, y equals -3. That is the equation. So if I'm asked the question, what is the equation of the line parallel to the y-axis that goes through the point 5, 2? So remember, parallel to the y-axis means it's going to be one of these, x equals something, just a number. Now, because it goes through the point 5, 2, the x-coordinate is 5, so x would have to equal 5. That would be the equation of the line, and it would be perfectly vertical. So these are special cases that you need to know of. All right. I'm just going to quickly write up the formula for you to copy down. So here is a list of formula you might like to copy down and study for the test. So I'm sorry that it's been a very long video, but there has been a lot to get through. The only thing that I didn't really touch on that much, you also need to be able to look at linear graphs and use them to solve problems. Like if I tell you the graph of a linear function is, distance and time, speed is just the gradient, you can still find the equation of that line in the same way. But make sure you're not completely unprepared for those worded type problems involving linear graphs. Other than that, thank you for watching. Sorry it's been a long video. You must be absolutely sick of my voice by now, but please make sure you ask your teacher for help before Thursday. I'm running a session on Wednesday after school if you want to come and get some extra help. Good luck studying. You've done really well. This is a really hard topic and I'm very proud of you. This has been the luckiest maths teacher in the world. Best of luck.